Hello, welcome to our project on the Quaternary period and the glacial changes that ensued during this time. In this video I'll cover the glacial movement that shaped the appearance of many of our mountains and distinct land features today, as well as covering what makes this period special and why it changes between ice ages and interglacial periods. Scientists have only recorded 5 major ice ages throughout the Earth's history, one of which being the Quaternary. The others were the Huronian, occurring 2.4 to 2.1 billion years ago, the Cryogenian, which was 850 to 635 million years ago, the Andean Saharan, which was 460 to 430 million years ago, and the Karoo, which was 360 to 260 million years ago. This suggests that the present ice age we're living through is likely to continue for a long time to come, as it's only occurred for 2.58 million years since the start, and it will have many sort of shorter interglacial periods like we're living through now in between these longer, colder spells. The period is most notable due to the ice age that has occurred, and it, as mentioned, led to warmer and colder spells. The cold spells occur for 100,000 years at a time, and the interglacial periods, the slightly warmer spells, only occur for 10,000 years at a time, both on average. The period is split up into 2 epochs to make it clear what part it is, and it goes from the Pleistocene, which is 2.58 million years ago when the period started, to 11,000 BC, to mark all the ice ages and previous interglacial periods before humanity's existence as we know it now, and the Holocene, which is from 11,000 BC to now, which is when humanity taken over and is the conditions that we're used to living in now. The Holocene is an interglacial period of warmth that, out of all these interglacial periods, occur for on average 11,000 years or so, and it has been in this time that the numbers of humans have rocketed, as I've mentioned. Even though it is evidently warmer now, interestingly, even with the heat and with it being a so-called interglacial period on the Earth, the entire Quaternary period has been part of an ice age, as throughout there has always been at least one permanent moving ice sheet, which at this current time is Antarctica. So how do these ice ages come about? An ice age appears to be induced when the continental crust prevents warm water flow from the equator, making the water at the poles freeze due to the lack of heat. Ice ages are when any part of the Earth is a permanent moving ice sheet, but these can also be induced in other ways, such as by a supervolcano eruption, which would create a cold spell for a very long time until the atmosphere will clear again. The reason this leads an ice age is because no heat can hit the water due to the sun being blocked out by the volcano debris, therefore freezing over water, which will move as it's on a plate. The reason interglacial periods occur is because of slight changes in the Earth's orbit, and then when more solar radiation can get to the equator and can get to the water, especially in summertime, it will lead to temperatures above zero, and the water won't freeze, and therefore there will be warmth over most of the planet. So what happened to the large creatures that adapted and we got used to the cold, such as the woolly mammoth? At the start of the current interglacial period was the mass extinction of the large herbivores such as the woolly mammoth, and as a result their predators as well. A theory for this mass extinction is the obvious rise in temperature and sea level, which they were not used to with their thick coats, but the suspected timing of the creature's extinction also came at a time when Homo sapiens, humans, migrated to the areas where these animals lived, suggesting that humans could have potentially been a factor. Despite this, it was still an ice age, but the reason for the developed mammoth coats was due to keep warm, with the same purpose as seen in many animals in the Arctic and Antarctic, with animals fur coats and certain animals blubber. So how has the cold ice age affected the land now and affected what we can see? Well, the glaciers are formed by a drop in global temperature, with the summer temperatures not being able to rise above freezing, the opposite to when it's an interglacial period, leading to some snow being unable to fully melt in some areas of the globe. The very bottom layer of snow is then turned to ice, and more snow settles, which is then too unable to fully melt. The weight of the accumulated snow and ice then leads to it pushing forward and its movement. The glaciers then change the Earth's landscape by picking up rocks and soil in the process of plucking, which will eventually deposit as moraine, eroding some hills and mountains completely in its unstoppable pushing force before melting when it reaches a low enough altitude to the heat. Another way of erosion is not just by plucking, and it's by crushing, where the large, heavy glacier will exert so much pressure it crushes the bedrock surface, leaving fractures called chatter marks, which are basically dents from pressure and just weight in these rocks. The glacial movements of these types create cirques, striations, and hanging valleys, all of which are common erosion to the land, or as common as this erosion can get. The cirques are valleys shaped like a half bowl or an amphitheatre, which is formed by the crushing weight of the glaciers breaks down from the rocks and soil beneath, forming a slight pit, which is a sharp mountainous hill on one side. Some ice from the glacier would remain in the divot, which would then eventually melt in a warmer interglacial stage, as we are now, forming a lake. Examples of these in today's landscape are in the state of Wyoming and the Cirque de Gavarnie in France. The striations. The striations are evidence of the movement of glaciers that is seen through grooves and ridges along a rocky surface have been carved out from a long period of movement. These striations can be caused by other heavy materials sliding across. An example of glacial striations at Scaffold Pike in the Lake District, viewable during the summit of the mountain. What also makes these glacial striations apparent is because they are on a very smooth surface of bedrock. These striations are caused by yet another process of erosion, abrasion, where the rocky surface is worn down by the grinding effect of the glacier. It's almost like sandpaper, which would leave a smooth bedrock surface with the mentioned striations, which appear as scratches all the way down it. Hanging valleys. A hanging valley is a separate smaller valley besides a main larger one, called so as it looks like it's hanging at the sides. They form when there's a connection of glaciers, a smaller and a larger one, which then melts, moves or recedes. The two glaciers then melt, forming the main valley and the hanging one at the side. And because these two glaciers were connected, it erodes a ridge between the valleys, connecting the two, and when the ice melts, it also may cause a river, creating a waterfall at the connection between the two valleys. An example of a hanging valley is Yosemite Falls in America, which is the largest waterfall in the country. The glacial erosion is particularly evident in the largest mountain ranges in the world and gives the mountains their distinct looks and predominant features, which is called glacial sculpting. The Himalayas, Alps and Andes are the most famous mountain ranges in the world, all of which have been altered by the process of glacial erosion from the ice ages. Glaciers still sit on top of these mountains now and supply rivers with fresh water. Currently, however, due to global warming with the fossil fuels we're putting out into the environment, many of these glaciers are melting because of the heat, which is not only contributing to the rise in sea levels, but is putting these incredible natural features at risk of being unnaturally altered, which would damage the landscape of many wonderful sites. Thanks for listening to my presentation. Bye.